Hi learners, we will understand about interfacing stepper motor with the 8051 microcontroller, and we are going to write a program for that. 8051 microcontroller we have studied in 4th unit clearly, and stepper motor basics you studied in lower semesters. Stepper motor actually rotates in stepwise. So stepper motor has a different coil structure, as you know, and this rotation is stepwise. Fine. So 8051, this one is 8051 microcontroller. What we see in the middle, the big box, is box 8051 microcontroller. These are crystal oscillators, this switch, that's not common thing, normal. And here we have to choose a port to connect the stepper motor. This motor needs 4 pin to be connected, so we have chosen from port 2.0 to port 2.3. Port 2.3. Yeah, this is the stepper motor interface. So this gets 5 volt input and it produces 50 volt output. This stepper motor has stator and rotor, as you know very well, and there are 4 coils. These coils are getting energized, okay, by getting numbers from the microcontroller. Anyway, we can send only numbers from the microcontroller. These numbers are sent as 5 volt output. Logic 1 is 5 volt, that's the thing, okay. So 5 volt is amplified into 50 volt and that is sent to coil, and the coil gets this 50 volt, and because of this voltage, and it is energized, and that becomes magnet, and that attracts the opposite pole of the rotor. So this is how it rotates stepwise, like this: step, step, next step, next step. I am drawing on the top, next step. It is rotating like this. So how this rotation is being done? Let us assume there are various logics based on the coil structure. We can make logics, right? So there are various logics. So now I am just choosing only a simple one, that is one. I am sending this number 1001. Say this one is connected here, right? So here I am just say this one, pin number 1 here, 1 2 3 4. This are connected here, these are connected like 1 2 3 4. This is the order, okay. This one is 2, 1 2 3 4. These pins 1 2 3 4 here, 1 2 3 4 is connected like this in the coil. Let us assume in this way. So here 1001. So how this number goes as 50 volt, here 1 0, and this is 0, and this is 1. So these two are magnetized, okay. So that attracts the opposite pole of the rotor. The next I am sending number 5, that is 0 1 0 1. So here that becomes 1 1. Second way, this is 1 is over, this is over, this is over, this is over, and this is over. So 1 0, this one becomes 1 1, and this becomes 0, okay. This, yeah, this becomes 1, this is already 1, right? So 1 0 1. So rotation, previously let us assume the pointer was here, and now the pointer is here, and the next I am sending 1, that is 0 1 1 0. So which means this becomes 0, and this is 1, and this is 1, and this becomes 0, okay. So here in this case it points in this way because the backside ripples, right? So, and if this side attracts and that side also, we actually have different poles, so that actually, yes, it creates stepwise rotation, so based on the attraction and repulsion, right? The next number we are sending it as 1010, that is A, right? So this becomes 0, this becomes 1, and this becomes 0, and this becomes 1. So this 1 moves here. So in all the things you just see this 1 moves here. So initially it was here, and next it has gone here, next it has gone, next disc gone here, and the next disc gone. So the direction moves. So this is how the stepwise rotation: 1 2 3 4 5 6 7 8 9, like that it goes on, stepwise rotation. If you put it in loop, then it will be an indefinite rotation. Okay, or if we have any number of specific steps, then we can have a counter, and the specific steps can be rotated 10 steps, 20 steps, 1000 steps, 100 steps, anything. So that stepwise rotation can be used in any embedded system, so that the mechanical operation can be done, whichever it is. Many examples are there, like, okay. So here this is our program. So port 2 has been chosen as output port because the stepper motor is an output device. So here it is output port, so obviously it has to be made as output port. So the 0 0 we are sending to make port 2 as output port. In this case, see, we are having only 4 line connection, that's 4 pins are connected, but we cannot send 9 alone, right? We cannot send 9 alone. Excuse. Yeah. Yes. We cannot send 9 alone. This one. Okay. We cannot send 9 alone, or 5 alone, or 6 alone, or A alone. Because it is an 8-bit microcontroller, we can send only 8-bit data at a time, and these registers are 8-bit. So we will be sending 09, 05, 06, 0A. Any of these zeros does not have any value because it is not connected with any pin. Okay, so that's the reason. So now we are sending 0 0 to make our port 2 as output port, so that we connect. Actually, we connected the stepper motor by seeing that we are sending this 0 0 as a to select it as output port. Okay, port 2 as output port, right. So 9 we are sending the first number to accumulator, from accumulator to port 2. So the port 2 got the output, the first rotation, first step done. Absolute call delay. So delay you can make any amount of delay, milliseconds, okay, and then microseconds of no use, because we cannot realize the microsecond step rotation, right? And it needs time also. The motor also, basically the mechanical structure of the motor needs time, the stepper motor, right? So here next we are sending. So first rotation is done, first step is done, so we called a delay, and next step is done, so that is 5 we are sending to accumulator, from accumulator to port, and we are calling delay. Next 6 we are sending to port, and then calling delay. The next A we are sending to port, calling delay, and SJMP, short jump loop. So this is an indefinite loop. So from here to here again, so from here to here again. So the motor will be rotating continuously until you press reset or until you close. Okay. So what is the delay program now? So delay, see here in between, so 4 times we have called delay. See, absolute call delay, here also call delay, and then here also call delay. So how much delay we need to make? So that's our choice based on the application, right? So this is our delay program. So the label delay is written here, the same label to be written in the main program. Yes, it was written. See here, same, the delay label. So here when you type the same program in the lab trainer kit, you will be writing or typing the starting address of this delay program. Okay, which one is delay program? This one is delay program. So what is meant by delay? The processor has to do some irrelevant work, unnecessary work, until we get some time. Okay, so first one step is rotated in the stepper motor, and then until before it goes for it actually goes for the second step, it needs to be, I'll choose a pen. Yes, so it needs, say, first step it needs to wait some time. So second, second, and then time, third delay, fourth delay, like that, right? So it needs to do some unnecessary work. Our main work is to send data to the motor so that the motor rotates, that is this rotates stepwise. And after we send, any of the processor can't be idle. So any of in 8086 we will be using NOP, no operation. Okay, that is also an instruction. So we will be writing continuously. So instead we make a register to, okay, this is wrong, okay, don't consider this 250, right? This can be done only in assembly, means if you use assembler, then we can make it. So let us take only the hexadecimal numbers. So here what is it? R0, I am just placing FF, okay, and here also I am just placing FF, right? So FF is 255, right? So 255 times, so what is it? So first you see FF is moved to R0, the same number is moved to R1. You can even reduce, not an issue. So and then next, what is it? Decrement and jump if not 0 to, if decrement and jump if not R1 is 0, then inner loop. Inner loop is the label name, okay, this inner loop is this. So it is jumping here itself. How many times? It decrements 255 times and it is jumping here itself. So after 250 times what happens? Then this loop closes, this loop disconnected, it's over, condition is false, right? So the next one is executed. So decrement and jump R1, right? So decrement and jump if not is equal to 0, R1 is not is equal to 0, delay. This delay is not jumping here itself, so it goes to loop, delay loop. So this delay loop is the label here. So this delay loop again reloads FF. So FF will be decremented to 0. This is one time. So here itself we get 255 times. Next, FF will be loaded again. That will be decremented to another 255. So this is second time. So we get 2 like that. Again FF will be loaded and it will be decremented to 0. The third time it goes on. Okay, it will be done up to 255 times. So 255 into 255 times, right? So we will be getting this much time. So that probably would give some nearly 0.5, 0.6 seconds. Okay, so the motor sends number 9 first to port 2, because we wrote the program like that. Okay, so the processor, actually the controller, sends number 9 to the motor. Here marker pointer, yes, the number 9 is sent, then delay is going to be, say an example, around 0.5 second. Then next number 5, so one step, then next step, third step, fourth step, it goes on. Okay, clockwise direction. If you want to rotate in clockwise direction, it should be 09, 05, 06, 0A. This should be the order. Anti-clockwise rotation, so it should be 0A, 06, 05, 09. This one is clock. Okay, clockwise. This is opposite. Okay, counterclockwise direction. So this is clockwise direction. For this we need to use this number, because based on the coil structure, this is counterclockwise direction. So this is how a stepper motor works. Yeah, so in this case, don't consider this as a decimal number 250. So since I wrote on the first page also hexadecimal, here also you use hexadecimal. If in case you are using assembly directives, then here you need to start with assembly directives org. Okay, here ending should be end. This RET is what? This is subroutine. This delay program is a subroutine. So whenever it is whenever the call instruction is used, See, whenever these are explained in the first unit itself, yes or no? So whenever the call instruction is used, obviously it goes to the subroutine, right? Separate program written for the specific purpose. Here the specific purpose is delay, creating delay. So whenever the RET is executed, then whatever the data is pushed into the stack will be retrieved, and it goes back to the just the actual position. Okay, the next instruction. That's what is the sequence. Okay, hope you have understood the program.